Hello. Our topic for today is about osmotic pressure and the relation of the solute and solution.
Let us first know what is osmotic pressure. Osmotic pressure is a colligative property of solutions that is observed using a semi-impermeable membrane, which means it is a barrier with pores small enough to allow solvent molecules to pass through but not solute molecules or ions.
The net flow of solvent through a semi-permeable membrane is called osmosis, which is derived from a Greek word osmos, which means push. Osmosis is the movement of solvent molecules through a semi-permeable membrane.
Remember that the direction of net solvent flow is always from the side with the lower concentration of solute to the side with the higher concentration. To clarify, osmotic pressure is the pressure required to stop osmosis in which, once the equilibrium is reached, the osmosis will be stopped by the osmotic pressure. Have you ever noticed your fingers? To relate or study in a real life scenario, have you ever noticed why your fingers look wrinkled when you take a bath? Osmosis is most likely responsible for this. When we sit in a bathtub or submerge our fingers in water for a while, they get wrinkly. And that is too because of osmosis. The skin of our fingers absorb water and get expanded or bloated, leading to the pruned appearance or the wrinkled appearance of the fingers. Now let us understand the cells behave in a different type of solutions. In this illustration, we can see that in the hypotonic solution, it has a lower osmotic pressure since the concentration of solute particles is less than the solution. While in the isotonic solution, it is equal since the solute concentration inside the cell is equal to the solution outside of the cell.
Meanwhile, in the hypertonic solution, it has a higher osmotic pressure since it has a higher solute concentration than the solution.
Now let us proceed with the computations.
Let's start with the first problem. What is the osmotic pressure of 298 kelvins of a 1 liter solution containing 37.3 grams of potassium chloride? Let's list down the given values. First, 37.3 grams of potassium chloride, then 1 liter of solution, then the temperature is 298 Kelvin, and of course, the R 0.0821. So of course, the required is osmotic pressure, and of course, we're going to use the equation for osmotic pressure. Pi is equal to m multiplied by r multiplied by t. So let's start. So let's list down 37.3 grams of potassium chloride times 1 mole of potassium chloride all over 74.6 grams of potassium chloride is equal to 0.5 mole potassium chloride. So 0.5 moles of potassium chloride all over 1 liter is equal to 0.5 moles. So let's start the equation for osmotic pressure. Pi is equal to m times r times t. So 0.5 moles times 0.0821 180 m over mole K times 298 Kelvin is equal to 12.33 atm.